let's just do this. Okay. Could I serialize intermediate forms? In some sense, yes. Can we use the compiler as a library? Maybe. If I knew the internals of the compiler, then yes. For SBCL, for example, it might be nice if I could somehow serialize the internal state, but I think that'd be too complicated. For our purposes, I don't think that's necessary to try to hook into the internals of the compiler. I think it'd be fine to just serialize the S expressions. But if we do have a form that we want to be able to serialize, provided it's not a function or anything, we actually do have software called CLStore, which serializes most Lisp objects. We can see which ones here. Basically numbers, characters and strings, vectors, blah, 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 blah. Even objects. CLOS instance is an object. So the only thing that it says it can't support, for the reasons that I discussed before, are functions and closures. It can serialize function names, so if a function has a name, it can serialize it, but otherwise it can't do any of that. So yeah, that's what I'd say is the answer. You could use the compiler as a library, but that means you're not going to have portable common Lisp code. And I think it'd be kind of difficult, but maybe it's something to take on. So I did this required slot stuff. So if I do, let's see, undefined function. Let me just restart this. Do all quick load, hypergeometrica. Of course. So now if I do make bin split, let's do in package. If I do make bin split series with, for example, A as lambda x, 1 plus x, for example, we get an error because we had a slot that we didn't put. So that's all these required slot things are supposed to do. So we have this, but this isn't really a representation of the bin split series. It's a representation of the form that we transfer. So this is, maybe I should say serializable bin split series. That's what that is. We'll need to take a bin split series and actually convert it into a something that we can compute with. Well, we can just call the compiler, I guess. So let's do. How should I go about this? Let's go to our scratch buffer. Let's put this back there, and let's actually undo the work that we did here. Where do we want to undo to? So the reason I'm doing this is because we'll still want this thing. Let's take out, I have to undo lots of stuff. This is kind of sloppy, but what can you do? So we want that still. That was kind of a long-winded way of doing this. Let's copy this back. Let's put this here. So we have our serializable. Now we need to define the then def type expression as that is t, and then we had the required function, required slot to define it. Okay, so we're back to normal. So the point is we need to write a function that converts this into this. I wonder how we do that. We spin up the compiler, be fun. Let's say, I should say reify maybe? Reify bin split series. So that's going to take a serializer bin split series, convert a serializable bin split series, SBS, to a split series. So this is just going to be a, let's compile it. What's the problem now? Oh. Let's do S series. S series and this. So make serialize. This takes A, which is going to be compile nil. Okay, actually what I'm going to do is eval sseries dot a SBS. We're going to eval it. It should turn into a function. Let's do this. Defun compile. So we take an expression, we eval it, let eval be eval expression, assert function p expression, and then compile nil expression. I think that should work. So if we do, oops, given an so this is multiple value bind the fn warns. So when you compile something, you get functions, warnings, and errors. We're going to return the function, but we also want to propagate these warnings and errors up into our actual Lisp implementation. So unless we have null warns, then we want to map nil warn I think this is what we want to do. Maybe error on warns, and unless null errors, want to map null error on errors. Okay, this somewhat complicated function, compile function. If I give it an expression like lambda x 1 plus x, let's see, what is it? Let's see. So it said it didn't get a function. What happens if we eval it? Oh. So if our expression doesn't evaluate to a function, then it'll evaluate to something else. So we give the expression that we had and the type of the result that we got. So let me show this. So if I do compile, where is it? if I do compile this, I get a function. Whatever, normal. But let's say I was compiling just to call the list. If I compile this, it says the expression list 1, 2, 3 did not evaluate to a function and instead evaluated to cons. Looks good to me. Let's try let x be 5 of lambda plus x5 or something like that. Yeah, that's normal. It can't. I mean, it evaluates the lexical closure, but then it doesn't know how to compile that. I wonder if we can just compile it directly. Compile no let x5 be lambda. I don't know. X. Okay, yeah, that's normal. So we can only do something that's a function. We cannot send it an expression which is a closure and expect that it can compile it into machine code. So that's fine. So now that we have compile function, what this is now is compile function of our series A. Whoops. Let's see. We have B, and then we have what? P and Q. So this is the same thing. A, B, P, and Q. So now we have a way of generating a new binary split series. New bin split series. We can reify it now. So let's try to go to one of our examples down here and do that. So let's do another version of this called S series, which makes make a serializable version of EXP series. So this is going to be just lambda make. So we have this. This is going to be an expression, which is just equal to 1. And this is also going to be an expression that's equal to 1. This one is a little more complicated. This is a function of n that has those and so on. So if we do this, let's see what happens. We have to inject x into this. That is very important. So if we do this, we have to put x into here. So if I do make exp series, exp series of, let's say we want to compute exp of 5 halves. Let's describe this. Yeah, we see that the first value is lambda n of 1, second is lambda n, blah, blah, blah. So on and so forth. That looks good. So now we want to reify it. Reify bin split series. Let's see, the error. Okay, this is coming from my reify function, or from compile function. It's this stuff right here. I'm going to my phone. Okay, I'm gonna take these out for now. Ignore and hash plus ignore. And let's try that. Okay, so we get the warnings. N is bound but not referenced. That's fine. And if we describe this, we now get this